Get some of that. Right. Can anyone tell me if you see a problem in the book and you really, you try some stuff, and I have no idea what to do? What should your immediate first step be? Huh? All right. When you're trying to solve a problem, you rule out use sub. Can you guys rule out use sub just by looking at it, Dan?
Yes.
Use sub is not going to work. Yes. Now, what I mean is you've already gone through that, and you tried some shit. You're like, I don't know what the hell this problem was. What do you do then? Do you erase it? Do the next problem on top of that and hope I don't notice you skipped it? That's what someone was thinking. All right, I don't want it, because it might work. I'm busy, so who knows? All right, now listen. How many of you guys have to go to like Calc 3? Get into Calc 3? How many of you guys need to take differential equations, linear algebra, tubular, kick ass? Now listen to me. You ready? The further you get in mathematics, the fewer freaking examples the book is going to have for you. I will never forget the first class. I had this stupid little book, cost $180. I thought I could rip a page out of the damn thing, go to Wendy's, and give me some lunch. Do you guys understand? Little thing of gold here. Let's do it. Crack it open, and I'm reading. I'm like, oh, okay, exercises. I'm like, wait a minute, what the shit? Where are the examples? Look at a freaking example. When you see a problem you don't know how to do, go look at all the examples they did, right? Love the shit that you have books that have examples in them still. Now, I know you don't know this, but I just told you. Further you get in math, the less examples. The more it's concept, and then anything. Use the concept. So, you look right here. Is it the same problem? Is it very similar? Does it have a radical on the top like ours does? Does it have an x on the bottom like ours does? So is it very similar? Yes. Do you guys understand? So that problem is really difficult to, without any assistance, figure out what to do, because the method you have to use is a little weird. That's why they gave us an example. They said, hey, this is a really weird application of use of. It's sort of like what we did before. Do you see how they solve for x and so forth? Do you see how we've done that before? Yes. But do you see what they do? They let u equal the radical on the top. So let's do this. They let u equal the radical on the top. So let me see. Can everybody do this for me? Everybody, if you haven't tried this yet, can you write this problem down? Write that problem down. Okay. Yes. 7.4. This is from section 7.4, number 50 here. Yeah. So everybody got it? You guys with me? Okay, so let's do this. Let's look back here. Let's all just follow the steps of the example. Yes? You don't want to do this with every kind of problem. You don't want to just mimic the steps for every kind of problem, because not every problem is trippy. Not every problem is, you have to be really manipulative with what's going on. Some problems are very straightforward, or more straightforward than this one. So in this case, I've got an example. It's a little weird, so they gave us an example, and I can follow the ideas that they used. So they let u equal the radical piece. So what are we going to let u equal? Yeah, we're going to let u equal the square root of 1 plus square root of x. Oh shit, you can't see what I'm doing. Let's see if could I possibly do this? Okay, so I'm going to do this, yes? What's the very next thing they do? Square it, so then I can start to solve for x. Our problem is a little worse. Do you guys agree? Yes. And if you haven't figured this out yet, I'm kind of an asshole. So I'll give you a problem that's a little bit worse, but basically every step still works. How do I solve this for x? What's the first thing to start solving it for x? What sucks about the x? It's under its own radical, and all of that is under another frickin' radical. So how do I start to unbury that x? What do I do? Same thing they did. Square both sides, yes? Isn't that immediately better? And real quick, why does it make sense? I want to call you this, because it's the most kind of messed up piece. And then what do I put down here? Well, if I solve what I just wrote, if I solve it for x, I'll know what to put down there. Do you guys see how I'm going to end up with something on the bottom that I could factor that then leads into partial fraction decomposition? Because that was the instructions, is that use sub to put this into fractional form, so you can use decomposition. Are you guys at all with me? Okay. And again, I am going to give you a few homework problems that kind of push you, but if you ever hit one, go through the examples. If there is absolutely 0 examples like the one you're looking at, get some help. And if it's the only problem you're having trouble with, or only 1 of 2 or whatever, then you're really doing fine. Some of these are just supposed to be a little bit beyond what we've gone over. It has to be. I have to try to let you make your own connections. This one has got a guide. It's got that example. All right, keep going. How do I get x by itself? Yeah, subtract 1. And then I square. Square. So now I know x is this. So just to remind us, I kind of wrote over this, but at the beginning we started with u equals the square root of 1 plus square root of x, yes? And then we squared it to get started to figure out what x is? Okay, so if I want to rewrite this integral, what do I put on the top? What do I put on the top? What did we say this was? We said it was u, yeah? Okay, not u, but u. What do I put on the bottom? What do I put on the bottom? Yeah, u squared minus 1 squared, because that's what the hell x is, right? Now, here's the part that students skip all the damn time. And you know from like section, the trig subsection, dx equals crap with theta. If you forget that, your whole integral goes crazy, yes? Dx is stupid important. I've gone to u. I need to replace dx with something du. Have I figured that out yet? Do I have a function of u? Do I have x as a function of u up there? Totally, so that's easy. To get dx, what do I do? What do I do to get dx? What do I do to get dx? Victor, what's the derivative of this? 2? Good. What's this guy? Why is he there? Chain rule. Kick ass. Okay. Stop for a minute. Now again, there are occasions where I have given you a problem because I know you have an example like it. So you're not like hanging out in the wind by yourself. You've got a guide. Will it be exactly like the example? No. Can you follow the rough outline of what the example did? Yes. So, your first thing you do, if you got a problem and you don't know, you tried some stuff, I have no idea, go look at all the examples they did in this section. There could be one that's a lot like it or a little bit like it. It might give you some ideas of what to try. Yes? Okay. So what do I put here now? So let me put dx here now, because I don't have enough room. So what do I put here now? Just all this business, yeah? I'm going to write 4u, u squared minus 1. Does anyone notice something kind of nice happen? I forgot my du over here. After making the whole big point about it, Jeff. Real quick though, I just made a mistake, didn't I? I forgot my du, but I know to kind of look for it. So when I didn't see it, I'm like, oh shit, then I gotta be careful. I'm like, did I forget more stuff? So make sure you got your integral piece and your d whatever piece. It's not a complete symbol without both of those. I call it like a bookend symbol. It's got a one side and the other side, yes? If you would have never thought to do this on your own, that's fine. Because we're all in the damn class, yes? You guys are all like learning this shit. So of course, every now and again, there's gonna be one that says, hey, here's kind of like a problem like that. Now try to do the same stuff. Because you're just learning, yeah? What's really beautiful that happens here? You know, one of these u squared minus 1s cancels, yes? And I can take 4 out and I get u squared over u squared minus 1. And this is the problem that just keeps on giving, because what do I need to do here? Long division. Let me show you an alternative to long division. Would you guys like to see an alternative to long division that is not synthetic division? What do you wish was on the top? What's the absolute best damn thing? There's one thing missing on the top that would have made this so nice. If only there would have been a -1. You guys agree? Because then this would have just been 1, and you can't beat that integral, yes? But there isn't, is there? So you're all like, yeah, Jeff, what good is wishing here, man? I've been wishing a lot, and it's never helped me in class. Okay. Watch this. This is kind of cool. So let me just look at this for a second. Don't we wish there was a -1? I'm going to put it. And then, but I better do what at the same time? +1, yes? What's u squared minus 1 divided by u squared minus 1? 1. And then I got 1 over u squared minus 1. That's the result of long division, but I didn't have to do long division. Can you do that all the time? No. You can only do it when you see the direct connection between what's on top and what's on the bottom, and you can't always see that, so you will have to do long division. But on this problem, the top is just missing a -1. So give it a -1, give it a +1, break it up, you divide it. Do you guys see that? And now you got to integrate that, and that's nowhere near as bad. That's where I'll stop. You guys, I'll leave you something for that problem. That was number 50 in 7-4. And if you just came in the middle of us doing this, we did not do this blindly. We did not figure out what to do for this problem completely. We realized there was an example that was just like it. So they didn't leave you hanging. They gave you an outline of what to try. And the reason that's okay to do every now and again is because what they did was not obvious, but it's really good for you to see the flexibility you have in what you can do. Yes? Okay. Sounding a little emphatic because one of my colleagues didn't appreciate this problem, and I kind of told him, do some examples just like it. What do you want from me? Anyway. So I don't know if you try this problem, you're getting frustrated. Always look at the examples. Yes? Okay. If you guys are in WebAssign, I don't know if there was an analog to this problem in there, so you might have missed out on all the fun. But if you're in WebAssign, you know there's an ebook attached, so you have access to all the examples. Yes, okay. Well, listen, I want to kind of focus either first or last on questions from homework. And then what we're going to do is we're going to do examples from 7-7. That was the Simpsons rule and the trapezoidal rule. Yes? And then we'll see what we got left at the end. I've got practice tests. We can even start looking at that if you want to. So listen, right now is the time. If you have a question that's irking you in the homework, let's look at it. If you're all like, I don't like help, Jeff. Don't, it's fine. Don't ask for it. Does anyone have? Yes, sorry. 53A. 7-1. Do. 53. Oh, okay. So they say example 6, right? So you look back at example 6, and there's the reduction formula. So example 6 was about proving it, and we can just use it. Now very quickly, you could look at their proof and go, oh, they proved it, so therefore we know this is true. For our problem, what was it again? Sorry?
53.
53. What's n for our problem?
2.
N is 2. Yeah. Now, real quick. If I ask you to integrate sine squared of x, do you need that? How do you do integral sine squared x? What identity do we know?
1 minus.
Maybe I should say it like this. What identity should we know? Yes, yes, yes.
1 minus
Cosine
cosine squared.
cosine 2 theta divided by
Oh, 2.
2. If it was cosine squared, it would be 1 plus cosine 2 theta divided by 2. That is just the double angle formulas for cosine solved for the squared other trig function. Yes? I need to make this really clear. All of you have to know what sine squared is, identity, and I don't mean 1 minus cosine squared, I mean the double angle part. Yes, you have to know what sine squared x is and what cosine squared x is. You know I'm going to give that to you on the test. You know you're going to get a problem like that. Okay. We stop there. You guys, you're all like barely tolerating me. I understand. Keep going that way. Okay. But for this problem, they want us to do it this way. So I know n is 2, so I can just fill in wherever I see an n, I'm going to put a 2. Yeah. And then you have to just show that it equals this. You guys with me? So in that case, I thought maybe it was like a, what the hell do they want me to do? Is that what the question really was? Use the results from example 6 to do that one. And the main thing you have to realize is n is 2. The minute you know what n is, you can just plop that in. Yes? Is that okay? And then part B is they give you a higher level power on it. So I'll let you guys try that one. By the way, real quick, okay. If n is 4, what does this integral right there become if n is 4? Sine squared. And didn't we just figure out integral sine squared is this mess? Isn't n 4? So that's what they mean by use part A and the reduction formula. If you use the reduction formula with n equals 4, that last integral is integral sine squared, and you can just copy the shit down from part A. You guys get that? Okay. That kind of question is different from the question you normally get, but that's what they mean. Somebody already figured it out for whatever n. We specifically have 2 and 4. Can you just plug shit in? You're like, yeah, I got that shit. You plug that in. Okay. So now, once I know what sine 4x is, sine 6x is easy. It's going to be a lot of writing, but I already know what sine 4x is. So I can just plug a 6 in, blah, 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 blah. And maybe. Got so much. Is that okay? Especially if it's going to ask, is that okay? Okay. Anytime I explain something and you're like, my God, it still doesn't make sense. Try again, Matt. You don't slap me, don't say that. Just say, hey Jeff, can you explain that a different way? Anything else from the homework set? Now's the time. 61.
It's the same thing where there's like an example thing, but
Sure.
I'm confused as to why it wants us to complete the square when you don't have to with the bottom.
Oh, well, there's a good example of this, like the one we just did. It said evaluate integral sine squared using the reduction formula from example 6.
Yes.
We just said we didn't need to, but it told me to. So it's trying to get me used to using something. And then part, so 61, if you see a different way to do it and they want you to do it this way, you have to do it that way. They just want you to get to practice with it.
Okay.
So what way did you do it, Sarah?
I just took an X out.
And put it where?
Like I took an x out of the bottom and it just became x minus 2.
Well, it becomes x times x minus 2, yeah?
Yeah.
Okay, yeah.
But then when you do that with the formula that it's telling you to do, formula 6,
Yes.
then it doesn't work.
Oh,
So,
alright, so now listen, if I gave you this problem, I would hope that a lot of you would do this, because then you could use what method?
the
If I keep circling it. Partial fractions,
partial
yes. Now, what they're talking about is formula 6, which is back here somewhere. Oh, here it is. Formula 6. Do you see that? So this is sort of like, this is kind of beautiful. It's exactly the one we just talked about. They have an interval that's been done for like a general A. So if I know what A was, I could just plug it in. So why do I need to complete the square? Because I don't have x squared minus a squared. I don't have a difference of squares, yeah? So this works if I have integral 1 over x squared minus 9, or some difference of squares, yes? So let me ask you this first level question. What if, so, very, 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 very first level question. What is the integral of dx x squared minus 9? And by the way, I don't know if you're like me at all, but I always hate putting my dx up there. I always like it like that. So what does the rule tell me to do? What's the only thing I worry about knowing here? Yeah, what is A?
3.
A is not 9. A is 3. Because this is a squared, yes? So a is 3. So then I just 1, 6. Do you see? I'm going to do this. Look at me. Watch. I'm going to point to the screen. Good job, Jeff. Do you see this is 1 over 2a, and we know a is 3? So I just put a frickin' 3 wherever's an a. I'm done. Yes? 1 over 6, natural log of x minus 3 over x plus 3. Pop plus c. Okay, now. So that, you with me? So if I put x squared minus 16, instead of 3's, there would have been 4's. Yes? If I put x squared minus 7, instead of 3's, there would have been rad 7's. Just the square root of whatever the number is. So that is a general rule for an interval that is in that form. So what about this interval? I don't know, Jeff. You do what? Hold on. Integral. Let's do it like this. X plus 1 squared minus 16. Is the bottom a difference of squares? All day long. Thing squared minus thing squared. Yes? What's A?
1.
What is it? Sorry? 4. What is A? 4. In the rule, where is A? It's the minus constant piece, yes? So the square root of 16 is 4. So it's stuff minus a squared. You guys see that? What's weird about what I just wrote? Stupid x plus 1. Damn it, Jeff. What's your problem, man? So I know a is 4 because a relates to the constant piece. When I gotta write this shit, I'm not gonna write x. I'm gonna write x plus 1. Because this is what happens if I have x squared. So if I have x plus 1 squared, I'm going to put an x plus 1 up there. So let's see what this looks like. Help me write it out. What was a again? 4. Yes, it'll be 1/8. Yes, 1 over twice a. Shit. It's too zoomed in. Natural log. X plus 1 minus 4 over x plus 1 plus 4 plus c. And then, of course, you can make this x minus 3, x plus 5. Yes? Tricky? Yeah, maybe. You could do u sub, but again, isn't this just linear? Doesn't it have slope 1? So it's going to act just like if it was at x. Okay. Deep breath. Okay, those are a little weird because you guys, it's really unfortunate. I want to say a quick thing since those last two were sort of related to this. Can you guys look in the very back of your book if you have your book? Starting on reference page 6. If you don't have your book, just watch. Look, gaze upon this. Okay. For example, right there, yeah. And look at this one. What if I turn them around? Right? 20 is like the one we just did, and 19 is what if I were turned around? Okay. Right. And then I got even more advanced. So, listen. To certify that I'm a complete nerd and geek, I have two. I have one giant reference book of intervals and then one pocket size reference book of intervals that if I was a real nerd, I would have on me right now, but I don't. So my credentials can be called into question. It's insane because you get up high enough in like a STEM field and then you're like, okay, math people, I love you guys, you're great. Holy shit, just let me get this. Somebody already doing an interval like this? And then I just got to figure out for my specific interval what's A and what's K and what's L, what's all the shit, and then I can see the formula. Because I got to just figure out what the magnetic field is at this point in space. So just, dear God, I don't have time to sit there and do all the substance. Just give me the goddamn rule. So there's that section 7.6, which is not part of our curriculum, that is all about using these forms correctly. But basically, we just captured it. Is my interval currently in the right form? Can I put it in the right form, and then can I identify the parts and plug those in? Yes? That's the skill of using tables. Okay. Are you allowed to have copies of this for your test? No. Stop it. Ha. It's too bad. So sad. Okay. But you can look at that. You look at all that. Okay. Anything else from homework stuff? Nothing. Okay. Yes? No? No. Okay. All right. So let's get back to this. Let me ask this again. Does anyone not have this handout from before? Does anyone need a copy of this?
Oh, wait, no.
I don't know. I think you guys get tired of me saying this, but you are not alone with your homework. Yes? You can reach out to the Math Science Center. You can reach out to me. Email kind of is the suckiest way to do any tutoring, but it's better than no tutoring. So I've had students email me over the weekend or something, and when I get to the email, I'll try to help you as much as I can. You guys are kind of with me. I've made Zoom appointments with students. If you're like, dude, I can only take you so much, then you got other people you can talk to, right? Hell, you can even bother my colleagues and say, man, that guy's weird. Can you help me? I think you're less weird, right? Okay. So you've always got somewhere you can get help, yes? And the first level, like I said, is examples. So last time we actually we devised a method to kind of verify this is true. This one is using trapezoids instead of rectangles. So the most immediate difference is that we've doubled some of the outputs in here. And if you remember why that is, it's because one trapezoid's base became part of the other trapezoid's base. So I used something twice in that construction. That one wasn't as bad, because trapezoids are pretty straightforward. They have defined area formulas. Okay. The one that was a little worse, but I got it. It's not surprising. I absolutely love the proof for Simpson's rule. If you ever find yourself saying that, you've made it to pure nerddom. And this one's really tricky because it's got 4s in it, and that one's a little harder to remind you of, but it was just because of the way I had to put together the y's. I needed 4 of the y in the middle to kind of make them become the other piece we saw from earlier. So if you missed that proof, you're okay. You've got the rule. The error parts, they don't even do the proof in the book. So I'm definitely not going to show that to you. That gets gross. I will have to show you what K is, and they do talk about that in the book. Just to show you. Because I'll write it, well, let's see. I want to show you first where it is in here. Oh wait, I went too far. You've gone too far, John. They give you the one for trapezoidal rule, the error bound. Where'd they do it? Here it is. There. For trapezoidal and midpoint. And you'll notice what K is. K is the biggest value the second derivative takes on between A and B. And what were A and B? It was your original limits from your interval. Yes? So it's kind of like the largest curvature of your function within that interval. Okay. That's trippy. And that's part of the proof, is that comes out. Notice trapezoidal rule is a cube, and there's a square in the bottom for the end. Midpoint is also a cube with the square in the bottom, but do you see how midpoint, all right, this represents the error for using n rectangles. This is how much my approximation is off by, yes? Maybe? So the more rectangles I use, obviously the less the error, right? Because I'm dividing by bigger. Okay. Over here, do you see how the midpoint error is, how does it relate to the trapezoidal error for the same number of rectangles? Which one's smaller? Trapezoidal or midpoint? Which one's smaller for a set number of rectangles n? Midpoint, because it's half the trapezoidal, yeah? So what's funny is, you guys learned midpoint before, yes? Left endpoint, right endpoint, midpoint. That one is better than the trapezoidal business that we came up with this semester. So go team. But we made up for that by doing Simpson's rule, and so the main thing I needed from that was to show you what K was. So let me put this down here. Because I don't think I did that. No, K is at most, it's the largest. Did I write that the right way? Yes. So it's kind of like the upper bound for my curvature. Same thing here. It's exactly the same way defined here. But what's true about this error? Why does this error? 2 reasons. Why is this error for Simpson's rule so much better than either one of those? And of course, with error, what does better mean? Small. So why is this expression for any given n smaller than either one of these would be?
Because you're fitting it curved better?
Oh, no, not the geometrical reason, but just the purely what part of the function, what part of this?
The bottom is with it.
Yeah, I'm divided by 180, for example, instead of 12 and 24, but I'm also divided by n to the 4th, yes? So this error gets small stupid fast, which makes sense because if I use parabolas to approximate my curve, it's going to fit much better than a frickin' trapezoid's going to fit, yes? Because it's still made with straight lines, okay? So the fact, I appreciate you're trying to explain the geometrical part, the fact that I'm using curved parts to fit my function, it makes sense mathematically why this sucker's better. All right, I love you guys. So let's do this problem. I want to use 6 subintervals. So let's do trapezoidal first. So you got the rule up here. Yes? can you guys take a moment, try to figure out everything you need, and then set this up for this function here. So you got the rule up here. We're gonna do trapezoidal rule for trapezoidal rule. Yeah, we're gonna do that first. By the way, does everybody see that function is 2 to the x squared, yes? Okay. So do you all understand that if I ask you to do this integral on a test, you could just kick me? Because, I mean, is there any damn way you can integrate this by hand? I don't know if you guys remember this. There's a integral e to the x squared dx. There's no way to do that by hand. Later this semester in chapter 11, we're going to learn an interesting way to approximate the answer to that integral to any degree I want to any decimal place. We're going to learn how to do that in chapter 11. And then there's a class called numerical methods, which is where you kind of brute force the answer. But there's no way to do that by hand. So that's why we're going to do approximation. So what do you guys get for delta x? Right, it's b minus a divided by n. Be 1/3, yes. 2/6, 1/3. The really nice thing is amongst all these different methods, delta x is just always the same little dude. Right? Thankfully he doesn't change with everything else. One good thing to notice about both Simpson's rule and trapezoidal rule, there's no left or right idea. You use every point. The first point, delta x delta, and then the last point. Use every point, and that came out in the derivation we did. I need to use every point because they define the bases of each trapezoid. Yes? So if I wanted to just set up the what this looks like, delta x divided by 2 would be delta x 1/3 divided by 2 is divided by 2, right? Divided by 2. 1/6, there we go. If I cut something in thirds and then cut those in half, I get 1/6. Of course, I write the word I'm saying at the moment. So 1/6. And then let's just write this all out. F of what? 0 plus 2 f of, how do I get the next thing? We already told ourselves what they're separated by, yes? What's the next thing? What's the width of each trapezoid? 1/3, so F, what's the next thing? F of 1/3, yes? Cool. Plus 2 times F of 2/3 plus 2 times F of 3/3 plus 2 times F of 4/3 plus 2 times F of 5/3 plus, and the last one is going to be when I stop at 2, so its coefficient is 1. Because I only use those outside bases once, yes? Yes? The number I put inside of F? Okay, so. I'm going from 0 to 2. And we know our width is 1/3. So I start at 0. Where do I stop after I go 1 width? So I just keep adding 1/3. So that's what the width does for me, is it tells me how far apart are the inputs I'm using. So once I know it, and I know where I start and then I add a third, add a third, add a third, add a third. And the only thing you gotta be careful about is don't put too many 2s. You gotta know when you're about to be done with it, so you don't put a 2. Okay. And you're not gonna have to memorize this. I don't know if I told you that. You don't have to memorize trapezoidal sentence rule, okay? Just have to be able to use it. So now, do you guys know, and of course I didn't bring my calculators, damn it. Do you guys know how to use the table yet? Yes.
I am not having to memorize it, you just need to put the formula on it.
I would put the formula on the test, yes. And then you really just have to kind of identify the stuff and put it together correctly, yeah. Oh, thank you, sir.
Someday.
It might have stuff in it, so you might have to clear it.
I like the color, it's nice. My calculator left. I gave it to somebody to take it to. All right.
Aw.
Yeah, lighten it up a little bit. Okay. So if I put the function in, so I can clear this, okay?
Yeah.
2 to the x squared. Just want to make sure you guys, because this is really useful. I'm almost certain you guys have all done this, but let me see. If I look at the table, look where I am. So, okay. Have you guys have looked at the table before on the calculator, yes? Do you guys see, I'm getting errors. If you hit your table button, you probably don't have this. But Sarah, at some point in the past, she got to the 53rd input. The reason it's saying error is if I do 2 to the 53 squared, do you think that number might exceed the calculator's ability to represent it? Yes, that's why the error is there. Okay. So here, all right. What's a really good button if I want to control what my table is doing? Does anyone know?
Calc?
No. Do you see right above window it says table set? So if you hit second window, I can then set up not only where I want it to start, but I can also set up how distant I want each input to be. So the table was starting at 53, and then the delta table was 1. 53, 54. Well, what the shit do we want delta table to be?
1/3.
1/3. So this is like set up for this kind of thing, because it's evenly spaced. Okay. Because I know some of you guys know about setting it to ask. Screw that even, because I have an evenly spaced set of inputs. Now if I go back to table, I've got all my stupid outputs that I need, yeah? F of 0, F of 1/3, F of 2/3. You guys with me? Has anybody done this before in the calculator? Anybody never done this before in the calculator? Does it make sense? Yeah, because you're not in Math 88. You have to show me you can plug shit in. The calculator's going to do it for you, yes.
Is there a way that that shows a function other than this?
In other parts of the calculator, you can hit the change to fraction button. Oh, I think you can change it. I don't know if I really want to. Oh, is it here? no, I don't know. That's the short answer is I don't know.
I know that you can do the whole thing with mode, but I don't know if it would fix,
Yeah, I don't know how to make everything,
or sorry, mode,
Fractional.
not mode.
yeah. But that's okay, because all of this is approximation anyway. So now I can do 1/6. I kind of want to do this, so here we go. 1/6 times 1 plus twice that would be 2.16 roughly, plus twice the next one would be about 2.72, plus twice the next one would be 4, plus twice the next one would be 6.86 almost, plus twice the next one would be 32. Okay. Not twice the last one, Jeff. The last one is not doubled, yes. So all I did was I took my outputs from 0 to 2, and everything in the middle I doubled. Right, the first one isn't doubled, and the last one is not doubled. And now if I add all this stuff up and divide by 6, I should get roughly what that is. Let's see. I don't know if I want to do that. Let's see. Shaboo! And divided by 6, I get 5.456 repeating. Is my approximate yes?
I think you missed a number.
I probably did. Let's
That's
see,
the
1 plus 2.16 plus 2.72 plus 4 plus 6.86 plus 16. Oh, do you think I missed a number in here?
One between the 6.86 and the 16.
Damn it! Let's see. 2.16, 2.72, 4, 6.86. Oh yeah, I did miss one. Plus, oh, that would be 13.7 roughly, okay. So let me come back out here. So let me go back up here. Plus 13.7 divided by 6. Okay. 7.7. Do you guys know how to do that interval? Have the calculator actually calculate the interval for us? I think I showed you that before, right? Since it's in the calculator, I go to second trace to calc. I can calculate an interval from 0 to 2, and I get roughly 7.34, and that's, pretty good for government work. And again, trapezoidal rule is worse than midpoint. So, that's kind of relatively far off a little bit. Yes? Okay. One really nice thing about the table of values we just did is if I have to also use Simpson's rule, it needs the exact same outputs, yes? So can you go ahead and try to set up what Simpson's rule would look like for this? So that would be this guy. Here, sir. Thank you. We already know what the right answer is. Let's see if Simpson's rule gets closer. Yeah, this is trippy with the alternating coefficients. So the first and the last one don't have a coefficient. Well, they have a coefficient of 1, I should say. 1, 4, 2, 4, 2, 4, 1. So the coefficients for Simpson's rule always end up being palindromic. And now we can just use the same values from before. See if Jeff can do it this time without missing anybody. So that would be 1 plus 4.32 roughly, plus 2.72, plus 8, no, plus, yes, plus 6.86, plus, I believe that would be 54.8, plus 16. Yes. And now I will do that in my head. Oh, that's neat. 9. Really hope I did that right. I'll go through 2. Put some 2. Double the same. Make sure I did this right. 1, doubled, the same as before, doubled, the same as before, doubled, the same. Oh, this one should be doubled, okay. So that would be 26, 27.4, okay. So that's f of 0, that's 4 times f of 1/3 and so forth, yeah? That's what I gave before, I got my 2.9, so that would be 65.5, I think, divided, yeah. I think you get 65.5 divided by 9? Would be something.
What did you say?
You got 70 some? Yeah, I'm fine
I
with it.
got
I'm trying to do this
7.
in my head, so. Oh, did you get 65.5?
No.
That's the part.
66.3.
Darn it. 66.3?
Yeah.
And when you divide that by 9, right? What do you get?
7.36 repeating.
And remember, the right answer was 7.34. Trapezoidal rule, we got 7.7 something, is that right? If I remember correctly? Which was really pretty decently far away from 7.34 to be honest. Simpson's rule, same number of subdivisions. Crazy close. 7.36. Okay. Alright. So there's a huge part of mathematics that's all about improving our estimation, because then we can make computer programs out of this. And they can calculate intervals of any kind of thing I can't do by hand. Just brute force by these methods, yes. If you do any computer programming, if you need, very often you're gonna need a computer program to call a subroutine that can integrate. And there's a whole swath of freaking integration subroutines. Anybody into any kind of programming, coding, anything? Yes? You guys know it all what I'm talking about? Anybody gotten to that point yet? You're like, dude, no. All right. What's your program of choice? What's your language? Anybody? What language do you like?
Python.
Python? Python? Anybody like Pascal? No, I'm joking. That's like the historical archives. All right. Okay. I'll leave it alone. Okay. So listen. Let's do this. This, don't worry about, okay? Don't worry about the error. I'm not gonna ask you about the error. We could calculate the error. And it's kinda obvious that the error for the Simpsons rule should be much less. We just saw that happen experimentally. Yes? It's based on the fourth power of the number of rectangles I'm using to divide, so of course it's gonna be a lot smaller. So experimentally, yeah, we saw it, it's much closer. In the same amount of kind of computing time. Okay, so much more efficient. All right. So let me do this, since you guys didn't really, I thought I'd get more questions from homework, but let me give you guys this practice test. And you can kind of get an early glance at it.
You got it, display fractions.
Oh, how'd you do?
So you do math enter in here, and you have to kind of like integrate it into the function that you wrote. It's really weird.
Oh, that makes sense.
It's really
I'm with
odd.
me.
But it just takes whatever output you had and it stuffs that into a fraction.
I
We'll
like
try
it.
it on this one.
I never knew you could throw that fraction thing into there. Yes.
And you can do it on the x's too. It's weird.
The what?
Force it. You can force it to be a
double
fraction in
equal,
here
yes.
instead of a decimal as well, and make the table x's into fractions as well. It's weird.
You wanna try it on here, Jeff?
Oh yeah, so all you have to do, hit y equals. Now go to the end of your function. And hit math to fraction, enter. That first one, just hit enter. Now hit table, go to table. No, go to table, sorry, second graph. It's gotta finish this thing, yeah. It didn't work.
I'm having some.
not-
It didn't work.
I'm having some particular trouble with the one that we've been using.
Oh, it might be
I can
beyond
get-
its capacity to do the denominator.
I can
yes.
get it to work with some equations.
That
So
would
like
make
1
sense.
over x. 1 over x will work. But I think we might just need to put it somewhere else. Maybe if I put it here, let me try this. If I do 2 to the x fraction, enter, fraction squared. Does that do it? No, that gives me an error. If I do 2 to the x fraction.
So you'll notice a couple things. For example, look at number 4.
What is it?
If you thought you disliked me before. Now, I'm bringing back an idea from Calc 1. How do I find the area bounded by 2 curves? Well, what do you subtract? The what one from minus the what one?
The top one.
So you gotta take a second to figure out which one of those is on top, yes? Not only that, sure. Not only that, but you have to figure out where they cross, yes? And I say in the first quadrant, right? So you wanna figure out, now say this is better on test, but just the first places they cross in the first quadrant, I want you to iterate between those 2 places. Yes?
Does it really matter which one's on top, because if it's negative, you lose your
So, if you put the wrong one, your answer's wrong. In the real world, you would just take the negative one, yeah? Is that what you're basically saying, right? If you put the wrong one first, your interval's gonna come out negative.
Yeah.
Yeah.
It's wrong, but if you just like
Take the negative one,
take the negative off.
exactly. But you're not in the real world, you're here, so your interval would be wrong. So part of the work is to figure out which one's on top. Yeah. If I was just doing this somewhere else, and I just needed the freaking answer, I got a negative, like, oh, I just put the wrong one first, who cares, right? Here, you gotta show me which one's on top. It's part of what I need you to see that you can do. I love you guys, you're all like, good lord, man, just give us freaking intervals, things like. How do I tell which one is, well, let's do this, how do I tell where they cross? What do I do?
Graph them.
No. Yes, but no. How to find how any two functions cross? What do I do with them?
Put them equal to.
Set them equal to each other. Yeah. Then you have a little equation you can solve. Everybody try. Try to set cosine x equal to cosine squared x. Solve for x. So we're just going to take the first two places they cross. Because obviously they're going to cross an infinite number of times, so that would be a little crazy. Does anyone know what to do from here? Gonna divide by cosine x. When you're trying to solve an equation, what are you not allowed to divide by? In general, what are you not allowed to divide by?
Anything that
No.
is more or less
Anything
than
you can't divide by
one.
0. Therefore, you cannot divide by anything you don't know the value of, because it could be 0. Yes. So I can't divide by cosine x because it could be 0. If you divide by cosine x, you effectively lose an answer. So what do I do instead? Yes.
Can we move to the side?
Yes. Set it equal to 0. Isn't one of my things squared? Gonna get it equal to 0, so subtract and then factor. Yes. It's the same old idea as before. If I have a squared piece, I can subtract this shit. I can factor it. Get each factor equal to 0. Yes. Okay. So how does that thing factor? So you got a cosine. And then what are your two little equations you have to solve?
Cosine.
Cosine x equals 0?
And cosine x minus 1.
Or cosine x equals 1? Yeah. When is cosine x equals 0? Pi over 2. And when is cosine x equal 1?
0.
0. Kick ass. So they cross at 0. That's the first place they crossed. And they cross at pi over 2. So now how do I tell which one's on top? So, I don't know if you guys are still caught. You don't have to graph the whole thing. At 0, where are they? 1. And at pi over 2, where are they?
0.
0. Yes? Is that cool? So how do I tell which one's on top? That's the two places they meet. Could they meet again in the middle of those two? Hell no, because that would have come out in my work. So between those two, one of them is always bigger than the other one. So couldn't I just pick a number in there and see which one has a bigger output to see who's on top? So I know they're both gonna have basically a curve. I just gotta see who's bigger than the other one, somewhere in the middle. So what's a nice number in the middle? Pi over 4. So what's cosine of pi over 4?
2 over 2.
Root 2 over 2. And what's cosine squared of pi over 4?
Root 2 over 2.
Just square this,
divided
yes?
By 2 squared.
What's the square of, what do you get when you square root of 2?
2.
Let me do it like this. 2 over
4.
4, 1/2. So which one of those is bigger? Do you guys know roughly what the square root of 2 is? 1.4 is good enough. 1.4, 1.4, who cares? It's about 1.4. Divided by 2 is 0.7, which is bigger than 0.5, yes? Which means the cosine is on top. which if you think about it makes sense. What do you get when you square a number less than 1? Does the number get bigger or smaller? It gets smaller. This is like a percentage of itself, yes. So it makes sense that the one that's not squared is bigger because they're both some decimal. So if I square it, it gets smaller. Okay. So I know at pi/4, this is at like 0.5, and the other one's like at 0.7. So the one that's on top, my picture doesn't have to be perfect, is cosine. The one on the bottom is cosine squared. Do you guys remember doing this at all? They gave you a couple functions. They said find out the area between them. So you had to do two things. You had to figure out where they crossed and which one was on top in that region. Yes? How do I set up my integral now? We know the limits, don't we? What's the limits?
0 to pi/2.
Well, we figured out what's on top. So what goes first?
Cosine.
Cosine x. Good. Now the really nice thing, of course, sometimes you guys forget, and not in a bad way, because you're worried about all the shit we learned. So right now you might be looking at it going, is that like a true thing? Or I have an integral of a function minus a function, so I can just split the integrals up. Yeah. The first integral is easy, integral cosine. Second integral, not as easy, but you all know cosine squared is identity. Finish that. Finish it. So this is an example of a process you guys used in Calc 1 that we're now able to do to funkier functions. You know how to find the area between any two functions. Just in Calc 1, we had to be very careful what functions we gave you because we can only integrate so many. Now there's a whole bunch of other functions you can integrate. You're like, oh shit, this guy's gonna make some weird stuff. Nothing too weird. Bless you. What's the identity for cosine squared?
1/2 times 1 plus
Okay.
cosine 2 x. Or 2 theta. Whatever.
To whatever the variable.
Yeah.
Yep. First integral easy, second integral easy but
Hmm.
not as easy. Yes? Okay. All right. I could take a 1/2 out, yes?
This should be negative.
Huh? How do I check? What's the derivative sign?
Oh.
Okay. So this will be minus 1/2 times, what's the integral of 1?
X.
X. What's the integral of cosine 2x?
Sine 2x over 2.
Good. Do you see how I could actually erase this here? I could just put pi/2 in the whole thing. You don't have to keep it broken up. But it's up to you. It's your deal. Which part of that problem was the hardest part? Was there a hardest part, or were they all kind of like equally difficult? Maybe the beginning? Very often the first step is the hardest part. Remembering how to get all the parts this kind of problem needed, maybe? Yes? If I ask you to find the area bounded between two functions, where do they meet? Which one's on top? Then you can set up the integral. Then it's a math 280 problem. What method am I going to use that we've talked about this semester? Yeah. So I'm just trying to show you that all the stuff we've done before could lead to an integral you could not do in 180, but we can do now. So sine of pi over 2, sine of 0, 0. Plug a pi over 2 in. What's sine of twice pi over 2?
2.
What's twice pi over 2? Pi. And what's sine of pi? 0. Good. And then plug a 0 in, I get minus 0. And then what's sine of 0? Plug a 0 in, I get 0. And what's sine of 0? What's sine of 0?
0.
0. Okay. How do I know sine of 0 is 0? What is sine like? Is sine like x or y?
Y.
Sine likes y. Yes? If you learn SOHCAHTOA, I am sorry. SOHCAHTOA helps you for this long. If you remember sine likes y, cosine likes x, everything makes sense. That applies for all time. Sine likes y. So if I'm at 0, sine don't like it there. So sine is all about the y piece of what I'm looking at. And if I'm at 0 degrees, what's the y piece of something laying on the x-axis? 0. So sine of 0 is 0. Cosine of 0 loves it there. It's all freaking x. And cosine, like, so it's 1. When it starts pulling away from the x-axis, that's when it gets scared. See that like a little turtle pulling in. Oh shit. Yes? 1, and then it goes down to rad 3 over 2, rad 2 over 2, rad 1 over 2, which is 1/2, 0. Yes? Okay. Maybe. And then that's your answer. 1 minus pi over 4.
Plus C.
No plus.
No.
Yeah. Okay. Okay. So let's see. Let's take a look here real quick. How you guys feeling about that? What two situations? Sorry, what two situations have been given you? You've got what's this?
That's a repeated.
Repeated. But thankfully it's linear. Yes. So the tops of both of those are going to be constants, A and B. Yes. This guy is. Can you factor this guy anymore? So we call him an irreducible quadratic. So what's the top of that piece going to need to be?
And
Like in the form ax plus b, yeah? Okay. And I don't want to repeat letters, but yes, in that form, yes. On the test, I'm not going to give you one that, it's going to have like 8 letters for you to figure out. You with me? Can you do the shortcut on what you're going to get? Can you pick a value for x? That would help. How do you tell? You haven't set anything up. Well, part of it's going to be x minus 1. So yeah, I can let x equal 1. I already know ahead of time that that's going to help. Okay. Does anything on here look like something you want to focus on right now? This one is obviously improper, yes?
Yeah.
What's up with this guy? Yeah, the 3 makes it improper. So I have to rewrite this as limit as t goes to 3, t to 5, blah, blah, blah. So the t is kind of what helps me. I'm able to work with a piece that makes the function freak out because I'm not really using that number. I'm using t as a little stand-in. Later I'm going to let it approach the weird thing, but right now it's just t. Yes? And do you see how I did there at number 6? That's exactly what I would do on the test. I would give you the full-blown stuff for each rule. Yeah. Okay. And of course I gave you a function that is not possible to do by hand. Can you guys? What method would you try to use if I said you should do this by hand? What method would you try to use?
By part.
By parts. Do you see how whatever this is, if it's a u or a dv, it won't work? If you make u equal to this, isn't it going to introduce a square root of x kind of chain rule piece?
Mm-hmm.
So everything after that is worse than it was to begin with? This is impossible to do by hand. So that's why we're going to use approximating rules. You can always do the thing we did to check your answer. Make sure it's close. Yes? If you do trapezoidal rule, it could be a little further away. If you do Simpson's rule, it should be pretty close. So let me ask you this, one more time. Is there any of these problems you kind of want to focus on right now? Which one? F?
Yeah.
This guy? All right, let's take a look at it. Let me say this right now. D is a trip. I'm going to talk about it next time. If you want to try it out, try it out. Do not freak out if you can't figure it out. It is not obvious. But I just put it here I want to talk about it a little bit. So we'll talk about that next time. If you guys want to try it, you can. Look at F. Does anyone have any, what do you guys notice about F that tells me kind of where to start?
That's
How many trig functions do I have in there running around? 3 of them, yes? What's different about them? True, good. One's is combined with another's power 7. But looking at just the trig functions themselves, one has an angle of 2x. That is where I go first, because otherwise they cannot possibly work together if they're talking about different angles. Let me stop right there. Do you guys get that? So if I give you an interval of cosines and sines of whatever secants and tangents, and one of them's got like 2x or half x, you got, all right, I got to deal with you right now, because it's never going to work with everybody else. Its derivatives are never going to look like anybody else, because they're talking about different angles. Damn thing. So do you guys know any double angle formula for cosine? The answer right now is no. You got some time. Remember that green sheet? That black line? Everything above it, I'm assuming you know. Because check notes, I'm an answer. That's right. Yeah, so cosine 2x. Remember cosine's the asshole, yes? So here's a real good situation. Cosine 2x. 3 ways to write it. Does anyone remember any of the ways to rewrite cosine 2x? The way I always remember is it's kind of like Pythagorean identity, except it's got a minus in it. And who goes first? Cosine, because he's an asshole. So cosine 2x is cosine squared x minus sine squared x. That is the one I always had memorized, and I just built the other ones as I needed them. And I've done that enough now that I actually have all 3 memorized against my will. It just stuck in my head. I'm like, all right. So I try to show you, well, not you guys, because I didn't teach you your trig identities. I didn't. But I try to show people, you don't have to memorize every damn one of them. Holy shit. You memorize one, and you see how to manipulate it to get other ones. So you have less stuff to kind of cram in your brain. So if I say cosine 2x is cosine squared x minus sine squared x. Now, this might be useful. I like it. Somebody sees this is useful. The other 2 ways to write this are 1 minus 2 sine squared, because cosine squared is 1 minus sine squared, so 1 minus sine squared minus sine squared is 1 minus 2 sine squared, or 2 cosine squared x minus 1. Both of those suck. Does anyone see, can you factor cosine squared x minus sine squared x? You totally can, right? What do you get when you factor cosine squared x minus sine squared x? Okay, poor little thing. Do you see how this one, if I replace cosine 2x with this, do you see how this one gets absorbed? Just becomes 1 with the other one. So I'll have 8 of these. And then what is the derivative of cosine x plus sine x? What's the derivative of cosine? Negative sine. What's the derivative of sine? So this is minus sine x plus cosine x, which is exactly what the shit that is, yes? So So that's just U sub. That is a U sub after you realize you need a trig identity. So you know I'm going to give you an integral where you have to do a trig identity first, and then you can do some stuff. You know I am. You sound so resigned. Okay. Do what you gotta do. But again, did you guys see what motivated me to do each of those steps? I knew the double angle had to change so we could play with the other guys. Then I had to make a choice. I had to memorize that first, and then I had to make a choice. Which one seems the most useful? Cosine squared x minus sine squared x. If I factor in, he's got a part that looks just like what's up there. And even from the very beginning, if you guys wanted to do U sub, what would you call U? Which piece of this would make the most sense to call U? What's stuck inside somebody else?
Cosine x.
Yeah, this! So if I said U equals cosine x minus sine x, or I'm sorry, plus sine x, because I didn't know what to try, what's du? Negative sine x plus cosine x. So then I get cosine x minus sine x, yes, thank you, dx. And so that would help me on this step to realize, oh, that could be useful because that is what du is. Okay, maybe. Real quick, what's sine 2x? 2 sine x cosine x. Yes, 2 sine x cosine x. So what's sine 4x? 2 sine 2x cosine 2x. It's a double angle formula. So whatever the angle is in there, I got to consider it to be double something. So 4 theta, 4x is double 2x. Yes, okay. All right. What method will I use on this one? Partial. What if I ask you this kind of question? If I left this blank and I said, what do you put up top so U sub will work? If you were the teacher and you're creating a problem, what would you put on the top of that so that U sub would work?
Y sub.
2y minus 4. How would I tell? What would you let U equal? The bottom. So what's the top got to be? Some multiple of that derivative. So I would take 2y minus 4. I would take 4y minus 8. I would take y minus 2. Any multiple of 2y minus 4 would work on the top. You guys see what I'm saying? So that's kind of like the next level of a problem is, what would you put here so this method would work? All right. This guy, what do you guys think about this guy? What part of this screams out to you what method to use? Anybody see it? There's an X with this other shit. So what does that scream at you should use? By parts. Good. I love it. You guys have done enough by parts. That's kind of like a real deal. That's like a traditional thing is X times some function you could do. If only the X was in there, I could do this other thing, that's by parts. Because then you can call the X dude du and get it out and just kill it. Yes? Again, not a life lesson. In life, don't identify the thing you don't let me kill it. It's bad. Don't say that. Gentleman to officer. Damn math teachers. They ain't nothing but trouble. That's an obvious one, yes? Is that all right to say? What do I have extra of?
Sine.
So what am I going to let U equal?
Cosine.
Good, because I can pull the extra sign with d theta, so I want U to be what makes that du. So U must be cosine. That's the whole idea with those. It's just a U sub that deals with specific functions, in this case trig functions. They're just U sub. I'm really curious how many of you guys are going to actually try D. We'll see. Okay. Thing is that thought there'd be more questions from homework, but that's really all I have. So you guys try to practice test out over the weekend. Whatever homework you've given me or whatever, I'm going to finish it, grade it. Yes. If you turn in some corrections, I'm going to grade those. Tuesday, I'm going to have the answer key for the practice test. Everybody got a practice test? Yes. Yeah, and just over the weekend, focus on homework. Look at this if you want. You do not have to do this at all. You could throw it away right now. You can make it into a paper airplane, throw it into a trash can. I'm going to give you the answer key. I don't need you to turn this in. Okay. Alright guys, have a good weekend. I know I will. We deserve it.
My first weekend when I don't have
Studying this weekend.
Yep.
last night.
Biology, my first biology exam on Monday too.
What bio are you in?
One,
Okay.
2:30. Something 30. I don't know. They dropped my bio class a week before the semester started, so I had to get into any bio so I could actually graduate this semester. Because if I didn't get into any bio,
That's dumb.
I would not have been able to graduate. So I had to take complete back because they had put a table in the bio class.
That's dumb. That
before
is
this
really
semester
dumb.
started.
That is really dumb.
But tomorrow's my
One open
last
session. I didn't
day.
get to choose a professor.
It'll all be over?
It'll all be